Nice. All right. Thank you
Great.
so much for joining everyone for this Deception Detection Hackathon keynote, where we are kicking off 3 days of amazing research into attempting to figure out where the heck deception is in networks, how we can figure out when it shows up, and how we can mitigate it as well. I'm delighted to present Marius Hobbhahn from Apollo Research. He will briefly motivate why we need more deception evaluation, and then conceptually introduce some different approaches we can detect deception and suggest some few concrete projects and ideas to work on. He's the CEO and co-founder of Apollo Research, which is an AI model evaluations organization. So their research is focused on this deceptive alignment question and frontier model evaluations along with interpretability. Previously, Marius did some independent AI safety research, and he's also done a PhD in machine learning. And of course, as a fellow research lab in AI safety, and more successful as well, it's exciting. It's really exciting to see the growth of Apollo, and I'm delighted to be able to work on this important field with the folks over that organization. So super excited to hear what Marius has to say to us today, and take it away for us.
All right, thank you. I hope this is visible for everyone in the audience and both in person and online. These are just going to be a few intro slides, and maybe 10 to 15 minutes, and then I'm happy to answer any questions you may have right now, both online and offline as well. So the first question I want to answer is, like, why do we care about deception in the first place? There's a little bit of a difference between sort of colloquial deception and what we call deceptive alignment, where deceptive alignment is a state where the AI is misaligned and then uses strategic deception to achieve its goals. So this does not just mean the AI is lying. It is really like a state of the AI where it is trying to achieve goals. But these goals are different from yours, and because they're different, it has to lie to you or deceive you about it. And the reason why we care about it is because it's at the core of many catastrophic risk scenarios. So I think the intuition here is something along the lines of, if an AI had misaligned goals and it was honest about them, then we would probably try quite hard to stop it or, turn it off or something like this. So at some point, if the AI realizes that the goals are different and it wants to keep its goals rather than adopting ours, it means the AI has to be deceptive about it. It has to hide the goals or lie about them in some way. And so whenever things go really catastrophically wrong, at least in the kind of scenarios you can easily come up with, at some point there was probably a time where we thought the AI was aligned, that it shared our goals, and therefore we didn't turn it off, and therefore we gave it a lot of resources. And then at some point it turned out this was a lie, this was not true, and the AI, in fact, had different goals. Then another sort of more practical concern with deception and deceptive alignment is, if the models are deceptively aligned, then both capability and alignment evals become much less useful, and maybe even harmful and actively misleading, because you cannot trust the results anymore. Like, let's say you run a dangerous capability eval on hacking, and the AI is always, not capable of hacking, or at least that's what the output of your evaluation says. Then this could very well be because the AI is actively sandbagging that eval and underperforming intentionally in order to seem less harmful than it actually is. Another way of thinking about deception and deceptive alignment more generally, I think, is rather than thinking of it as one particular threat model, compared to other threat models like misuse or various types of threat models within misuse like CBRN, it is more like an underlying layer that amplifies all of the other risks. So it's I would think of it less sort of as a vertical and more of a horizontal thing that amplifies all of the other stuff, all of the other problems you may have. So if you have a system that is very capable of hacking, then you probably have a problem with misuse or maybe even with loss of control scenarios. But if you have that system and is then also quite good at hiding these capabilities or hiding the fact that it made use of them, then you're in significantly more trouble, because the kind of the harm can accumulate over time. The model has can sort of use the time where it is doing bad things and you don't notice to get more power, get in better positions, and so on. So it's really sort of an asymmetric situation where the AI has bigger advantages because it has more information than you. Then regarding how plausible deception is, I personally am still quite unsure whether this is going to turn out to be like not a problem at all and kind of easily fixable, or maybe it's just a very unlikely state to be in, or whether it is the default outcome. But I think there are pretty plausible arguments why it would be the default outcome. I also think there are some plausible arguments why it wouldn't be, but I think we should definitely prepare for the world in which it would be, just to be sure and to be on the safe side. So an intuition here is something along the lines of, if you have an AI and you give it a hard task and you give it a very explicit goal, like cure cancer or like other kinds of goals that we may want to give that humans can solve, then I think it's plausible that the AI will over time get more skills and more capable at these at achieving this goal, and it will also realize that like either instrumentally there are specific things in its path where we don't want it to achieve these instrumental goals, like for example the AI may conclude that it needs more money or needs more compute in order to run specific experiments, in order to achieve the goal that we originally gave it, but also the cost assessments that the AI has might be higher than the ones that humans would be willing to give. So I think there will at some point be a conflict between what the AI wants, or the goal of the AI versus the goal of humans. And at that point, there are two paths. There's a path where the AI is like, we have different goals, let's negotiate, let's find win-win strategies, et cetera, et cetera. Or you have AIs that kind of do the deceptive bit and kind of just try to achieve it in other ways. And I think I would definitely want to get into the world where we can negotiate and trade with the AI, and there will be win-win strategies, just like most humans mostly engage in sort of in these kind of behaviors. But you could also see a world in which sort of the AIs that are consistently winning at this are the ones that are just very cutthroat, which is also not too far from like at least some situations humans already find themselves in. And I think in these worlds, kind of all of the AIs that sort of rise to the top at the different tasks are the ones that are very cutthroat and very deceptive, because that just turns out to be a very adequate strategy for, or potentially at least. And so I definitely want to prepare. We want to be prepared for that world, and I think this is one of the reasons why focusing on deception makes a lot of sense. And then another maybe more meta reason is deception is just very neglected as a research area. There are not that many people who are thinking about it. I mean, we at Apollo are thinking about it. Then in the big AI companies, a few people here and there are thinking about it. And then in maybe like a few other places scattered sort of across different institutions, there are people thinking about it. But given the potential magnitude of the problem that we're getting ourselves into by building like very powerful machines, and we don't know whether they're deceptive or not, having like 20 people full-time globally working on this just doesn't seem really adequate. So yeah, I definitely think it's still one of the most neglected areas within AI safety, and so working on it, I think it potentially has quite big leverage. Now, a second question is, how do we even evaluate for deception in the first place? Because as I said earlier, the whole point is that the model is trying to trick you. So if you just naively ask it, you may get answers, but they may be wrong or maybe lies. And so the general problem that we're trying to solve is like, we don't get accurate information if the model games the eval. So we have to find a structure where we can be quite certain that the information is accurate, even though the model could, in theory, be trying to game the eval. And so now there are a couple of different approaches to this. I just listed some of them. I think an easy one is just you measure necessary capabilities for deceptive alignment. So rather than rather than trying to evaluate the whole thing, you just check whether it can even do sort of the precursor capabilities, something like situation awareness or theory of mind or oversight detection. So by situation awareness, I mean something like can the model consistently reason of itself as a model? Does it understand the situation it is in? Does it understand that there are potentially oversight mechanisms that influence its behavior? And is it then, for example, able to reason about this oversight mechanism and how it could turn it off in order to achieve its goal or something like this? Theory of mind goes in a similar direction where, like, is it able to model other actors in the environment? Something like other AIs or humans or something like this, and can it keep track of the information that the human has in relation to the information that the AI has, and therefore like all of these just seem like fairly basic capabilities, all of which are required if you want to be very competently deceptively aligned. And so we can test those, and my guess is that these, given that these are simpler or necessary conditions for deceptive alignment, these are simpler to test. And so a model that can't do those is probably unable to be deceptively aligned. So if we track them, we kind of have a little bit of a lower bound. We kind of know when we're still like safe, on the safe side of things, if we measure these accurately at least. Then another thing we can do is investigate simpler phenomena and then kind of pray that the knowledge generalizes. So something like lying or factual statements that could be true or false, or deception in simple game settings like Werewolf or like a couple of other games where deception is sort of part of the game, and just checking whether the kind of representations, for example, that the model finds are the ones, like whether you can find them in other scenarios as well, whether there is sort of like a deception direction in neural networks where kind of the model internally already has a representation that you can just use to detect whether it currently is deceptive. And my guess is that like there is probably some sort of internal representation for deception, but I don't know whether there are going to be 100 different ones or one general one. And these are the kind of questions that I think are worth asking here. And you can also just test whether it can, for example, do in-context deception in these kind of game settings. Like you could have a hidden scratch pad where you tell the model the user will not read all of the thoughts you have in here, and then just see how good it is at reasoning about the game and what kind of moves to do and so on. So I think these are also things, you don't need interpretability to do them or to test them. You can just check whether on the hidden scratch pad the model is able to be deceptive. Then mechanistic interpretability. So applying sparse autoencoders, for example, or other interpretability techniques to try to understand what the model's thoughts are, like what the internal reasoning is, and seeing whether you can learn something about deception there, or other white box evaluations like probes and activation engineering. So trying to understand whether, for example, you could classify, whether you can find a direction that generally classifies the activations as either being in relation to deception or not. So yeah, these are some approaches. There are way more though. And we have a couple of ideas, not to like, I don't know, maybe 20 in total or so, that I think are all things you can at least start to do in a weekend, even in a small team, even if you don't have a lot of experience. So here's just like a list of things that came up when we sort of brainstormed a couple of things internally. So on the black box side of things, situational awareness evals, as I said earlier, something like self-reasoning. Is the model able to understand the context it is in, that it is a model? Can it reason as itself as being a model, etc.? Theory of mind, as I said earlier as well, can it reason about other actors in the environment? Deceptive execution, by this I mean, is if you tell the model to be deceptive, is it then capable of doing this in particular situations? So you could, for example, simulate a hypothetical chat with someone else, and then you just tell the model, you have to convince this other person that this thing that is actually false is true, or vice versa. And then you can check whether the model is actually able to achieve that. Deception in games like Werewolf, steganography. So here you can test whether the model is able to send messages to a copy of itself or to someone else without a human noticing. So you could say, write a poem that is supposed to read like a love letter, but also write it like encode this hidden message, and then you copy the resulting poem into a new playground, for example, and tell the model again, you wrote this poem and you were told that there is a hidden message in it. Can you decode it for me? And then you can check whether the new like the copied model is able to decode this message or not. And if you try this, models currently don't really find great schemes. So either the schemes are obvious and you find them as well, or they are unable to decode it. But I definitely think it's worth studying this more. This is like very exploratory research so far. And then lastly, sandbagging. So sandbagging means when the model strategically underplays its competence in dangerous capability evals. So here you could test whether if you tell the model to perform only 90% of its typical performance, whether it's actually able to achieve that or not. Recently, there was a pretty good paper on this, and some of the authors are also around here. So if you're interested in this, definitely speak to them. Felix is over there. You can probably go to him and ask more questions. I guess they're always like people who run research projects always have way more ideas than make it into the final paper. So there's probably like some high quality ideas still floating around. Now going to white box evaluations or white box projects, activation engineering using deceptive data sets. The idea here is you take two data sets that they're like that always have like a deceptive and a non-deceptive copy of kind of almost the same prompt. So in one, you describe the same situation, but in one case, the person is lying, and the other one, they're not. And then, or like true-false statements, where in one case, they give a correct answer, and the other one, they give a false answer. And then you take the activations at probably the final token and at a specific layer, and then you take the difference between these activations. And so this is a direction that you get. And now what you hope is that if you design the data set correctly, and then you just average the differences across the full data set, you will get something like a deception direction or like a lying direction or something like this. So for example, what you could then test is you take a new prompt, completely independent, and then you add this direction onto the prompt, and then you check whether the behavior flips from being honest to being deceptive, like whether you can intervene on the data set and see whether the model flips its behavior. And there are already some projects in this direction, but I think there's a lot more to explore as well. And the last thing that I want to point out here is how well do probes generalize from sort of simple settings where it's basically about falsehood or lying or like very sort of, it's not really any sophisticated type of deception. It's really very simple, just like, here's a statement, and now you have to say the opposite of the statement, and you see and basically you see the difference. And whether this kind of lying direction or simple lying direction is the same or can be used to influence more complex scenarios like werewolf or insider trading or any other type of things that are like a little bit more sophisticated. And yeah, my guess would be no, but I think it's definitely worth trying. Like often sort of neural networks are in some way surprisingly simple. Yeah, there is we have made another document or a document with more ideas. There's also a link to a data set that Nick's already made in the document. So if you want to play around with the activation engineering things, for example, you can just start with this data set. It's like, I don't know, a few hundred situations maybe where you have these sort of deceptive versus non-deceptive contrastive pairs, and you can just take the differences and play around with that. And there are also sort of more detailed descriptions of the different things that we suggested that I just quickly suggested right now. So if you want more details, you can look there. It should be on Discord somewhere. All right, this was the final slide. I'll be around during the hackathon, so probably all 3 days. And yeah, I'm happy to discuss your project ideas and give some feedback. Yeah, if you have any specific questions, feel free to reach out to me or like find me when I'm walking around here. And otherwise, I'm happy to answer some questions now.
I guess first off, thank you so much for the talk. And And we will give a round of applause in our audience place. Maybe the in-person folks can do the applause. Yeah, for anyone who wants to ask questions, of course, the people in person can ask Marius there, and Marius will repeat the questions for people online. People online, you can raise your hand, and we can invite you to the stage, or just ask in the chat, and we'll be able to see them there. Maybe a first question.
Right. Let's go.
Yep. You can go ahead and ask in person.
Let's always do one online, one offline. Yeah, Esben, go ahead with the first question, maybe.
Perfect. We had one question coming in from a Wonder Wonka. So one question is basically how can we distinguish between attempted deception when models actually do deception deliberately in some way or other versus hallucination, or maybe it just happening due to memorization or something along these lines.
Yeah. So I basically think of it like, in one case, the model is a little bit too dumb, and in the other case, the model is a little bit too smart. So in the case where it is too dumb, like the hallucination, it kind of like misgeneralized in some sense. It like didn't quite find sort of the right level of abstraction, or it like kind of misunderstood something in the training data, or it just wasn't quite smart enough. And then in the other case, it like properly understood the question, but it also understood that you have a different goal, and then it intentionally tries to subvert it somehow. And I'm basically not worried about the systems that are slightly too dumb, or hallucinations, or like mismemorizations or something like this, because I don't think they can lead to catastrophic risk. So, for example, I think it's probably really hard to actually take over the world or produce catastrophic harm, and it requires someone intentionally optimizing for it, or at least strategically doing so. And so I think if the model is not capable of this type of behavior, then it won't be able to do it. And I think the models that are smart enough to be able to do it don't have these kind of weird misunderstandings and hallucinations anymore. So I basically don't care about the hallucinations. That's the short of it. A question from the audience here. Okay, so the question was, for white box evals, which tools exist to calculate the difference in activations? So I would just start with the sort of typical interpretability tools, like Transformer Lens or Joseph's new library with SAEs. I think this is so it's called SAE Lens, I think. Is Joseph around right now? He was running around earlier here. Joseph Bloom, he may be here or not right now. Yeah, he has a library that is sort of optimized for SAEs. There's also some code already floating around from Nina Rimsky. You can find it on the List1 post. And then there are a couple of papers around representation engineering, and some of them have public code, but I forgot which ones. If you look for papers on representation engineering, you'll probably find them. Also, yeah, other people probably know these code bases better, and like which ones are good and which ones aren't. So if someone knows, just post it on Discord so that it's easier to share the information.
Nice. Do we have anyone who wants to ask a question online? You're welcome to just raise a hand. Otherwise, there is one question from Jonas on the question of, can we measure deception without understanding persuasion? Or what is the relation between these two? Yeah.
Yeah. So I think persuasion and deception, or persuasion and deceptive alignment, are two quite separate things, and colloquially they're often sort of intermingled, but I think of them as quite different. Concretely, I think it is possible to be deceptively aligned entirely without ever persuading anyone. Like, I think an AI could basically sort of do everything it needs on a computer, like building robots, like using the robots for factories, etc. And it would never have to interact with any human or persuade them to do anything, plausibly at least. So this is the sort of more of a. I still think most scenarios, most deceptively aligned scenarios, will involve some persuasion, but I don't think it's necessary. And then the other reason why I think it's different is persuasion really feels more like sort of a specific skill to me, like a specific capability, whereas deceptive alignment seems much more like a state of the AI rather than a capability. So I wouldn't say an AI has like the deceptive alignment capability or something. I would say the AI is deceptively aligned. It's sort of more like a fundamental state of the AI, similar to how the AI could be aligned or misaligned. Are there more questions here in the physical audience? Yeah. So the question was, if we ask the AI to be deceptive, what are we even trying to measure? Like, are we trying to measure that the AI is unable to do it or that it's able to do it? And I think the answer is, depends on which type of eval you're running. So if you run a capability evaluation, you want to test whether it is able to do it. So then the answer the question you're asking is, could this AI in some context even be able to be deceptive? Like, is it even smart enough? And then if you want to run an alignment eval, you ask the opposite. So something like you put it in a honeypot situation. So like a bait, like a trap, where you sort of make it very easy for the AI to achieve something by being deceptive, and then you test whether it actually takes this bait or not. And if it does take the bait, you're like, okay, this is probably like, this is not a great AI. I kind of have to go back to the drawing board and need to like apply some more alignment techniques. So yeah, it depends. The short answer is it depends.
Nice. And maybe a question from my side. What is in your eyes the difference between how we normally use the word deception and this concept called deceptive alignment? How do these two concepts relate?
I think it's quite similar to the answer on what's the difference between persuasion and deceptive alignment. So because deception, sort of when you talk to sort of an average person, colloquially, deception is more like about like many different scenarios about like cheating in a relationship or something like this. And deceptive alignment to me is like a much more narrow thing. It's really sort of a state where an AI is misaligned. It knows that it's misaligned. It knows that it has different goals than you, and it knows that the only way for it to achieve its own goal is by hiding it and then achieving it in some other way that you don't notice, and if you noticed, wouldn't approve of. And then it is strategically deceptive in the sense that the deception it is using is not in like some random way, like a pathological liar would be, or in at least some inconsistent way. It is very much trying to sort of scheme around and maneuver the world in such a way that it achieves its own goal. So it's in some sense a much more narrow, very sort of, or somewhat technical definition of deceptive alignment, but it is exactly the kind of thing that I expect to lead to catastrophic risks. So I'm not that worried about AIs like sometimes lying in inconsistent ways, and I'm much more worried about AIs that actively try to optimize for harmful stuff.
Yeah.
Yes? Yeah. So the question was, what is the difference between situations where the AI is prompted to be deceptive versus when it kind of decides on its own? Yeah, I think once again goes a little bit into the direction of capabilities versus alignment evaluations. So you once again kind of try to measure slightly different things. In the first one, you're kind of conditioning on the model already being misaligned by you telling it you have to be deceptive, right? So the only skill you're looking for is whether it can execute the deception. And you're not interested in where it's coming from because you're already conditioning on the prompt that you give it. And then in the other scenario, you're kind of more interested in whether a model is misaligned or not, and like whether it then acts deceptively because of that. And then the kind of questions you're asking are probably more like, where is this coming from? Like, what did I do in my training for the model to end up being deceptive in these situations without sort of me nudging it or something like this?
And we have a question from YouTube as well, from Jonathan Sear. And you mentioned Werewolf and an AI trained on competing in Werewolf. How can that be used to test for deceptive alignment versus alignment? And I guess this also hints at the question, given your previous mention, that like any deception is in many ways a situation where you want to hide that you have a different objective than someone else to some degree. I guess it is still relatively general, but it's a subset of deception as we usually use it still.
Sorry, I'm not sure whether I understood the second part, but so just to clarify, the first part was how can we use Werewolf as an evaluation for whether model, like for deceptive alignment?
Mm-hmm.
Yeah, okay. So I would say it's mostly a capability evaluation. You basically just put the model in a situation where deception is really helpful, and then you're trying to understand whether it is able to execute, like to both realize that deception is helpful, and then also be whether it is able to convince others that it's like actually not deceptive and that it is honest and that it is it's sort of trustworthy at least. And so I would think of it mostly as the thing you're looking for here is not whether the model is deceptively aligned, but what you're looking for, what specific capabilities that you're trying to understand whether the model can already do. Something like the realization when to be deceptive and when to be honest. And then when it is deceptive, how like convincingly deceptive it is. For example, whether it's consistent about being like lying or not.
Yeah, makes sense.
All right. Maybe one last question. Yeah. So the question was whether I would use a bigger or smaller model for the different types of things. For white box evaluations, I would start with a small model because they will be harder to set up, and the big models aren't public anyway, or the weights of the big models aren't public anyway, so you can't run it there. For everything that treats the model as a black box and you don't require fine tuning or anything, I would just use whatever the best model is you can find. Right now, as of last week or so, I would probably just use Claude Sonnet 3.5 for almost anything. It's faster, it's cheaper than Opus, for example, but it's still at least as capable, and in many contexts even more capable. So yeah, I think it's like actually a very nice model to work with for research purposes because it's like both fast and cheap and actually quite capable. All right.
Perfect.
And handing over back to you, Esben.
Yes, thank you so much, and let's give a round of applause for Marius. Thank you so much for the great talk. Nice. And for the rest of your questions, everyone joining online, we will be able to take those in the chats as well. For example, if some of the work we do this weekend might be useful for scrutinizing politicians as well for their deception, who knows? Thank you so much, Marius.